Oh, kids. All right, we are going to, or at least I'm going to talk you through this lab because some of you struggled a little bit. So remember, it is super duper important that you understand, think, understand. So even with this, if as I'm going through this, if there's something that doesn't make sense, ask questions. Okay, like come see your teacher, go see the tutor, ask questions. Don't just be like, I don't know. Okay, it has to make sense to you. All right, so you were first supposed to draw an FBD of the car going down the ramp. Now you were supposed to draw it over here. I'm just going to draw it here. So here is the ramp. Here's the little car. We're supposed to draw the forces acting. Well, you know what? There's a force of gravity acting straight down. There is the force of the track acting that way. And then you're supposed to find the net force. Okay? This, ladies and gentlemen, is where you have to think about adding vectors. How do you add vectors? You add vectors tip to tail. Are these vectors tip to tail? The answer is no. So then you have to move them so that they are tip to tail. So you would have the force of the track and then the force of gravity. So this would be the force from the track, and this would be the force of gravity. Then you need to find your net force. Well, the resultant or the net always goes from your start to your finish. So where did I start? Well, I started right here. Where did I finish? I started right there. So it points that way. That's the direction of the net force, which just happens to be down the incline, which means it's going to accelerate down the incline. Okay? But make sure that that makes sense. All right. Then you were supposed to go and you're supposed to collect some data. Okay? Couple things I want to mention. Okay? Your data, this is in meters. This is in meters per second. All right, a meter. Okay, everybody take your hand and go, your two hands and move them so they're about 3 feet apart. Everybody doing that? All right, 3 feet apart. That is roughly a meter. I had some of you telling me from the beginning to this photo get right here was 30 meters. No, think about that. 30 of those. Everybody got your hands about 3 feet apart? 30 of those. No. It said 30 centimeters, which is going to be 0.3 meters. Okay? You need to have, like, it's not so much that you made the mistake, like, or, the first time. It's that you kept going with it. That's the part that bothers me, because then you're not thinking about it. So you have to think about it, okay? The other thing that was driving me crazy, I had some people say for like this velocity, they got 60 meters per second. Okay, to go from meters per second to miles per hour. And you're going to write this down, folks. To go from meters per second to miles per hour, it's roughly times 2. That means if you wrote down 60 meters per second, that means that car, that little Matchbox car, was going about 120 miles an hour when it got right there. No. Again, it's not so much you made a mistake. It's the fact that you looked at it and you didn't go, oh, that doesn't look right. So you need to think. All right. So I just have one data point. You, of course, are actually going to go back and get all of the appropriate data points. I am going to assume that for me, so when you graph this, you should have gotten this data point. We know that that data point is 100% accurate because at 0 time, it's not moving at all. And then you should have gotten some data points that look something like this. Okay. Now I am going to say that data point 8, 1, 2, 3, 4. So let's say we got something that looks like this. Okay. So I'm going to say data point 4 when I graphed it. And you guys, of course, use the app. But you see how data point 4 for me, okay, you, however, are not allowed to use data point D. Why? Because I'm using data point D. And you need to think, and I want you to think back. But for me, I'm going to assume when I graphed it, hey, look, this data point's a little bit off, this data point's a little bit off, but data point D was perfect. And then I was supposed to label data point D. So I got 1.0875 seconds, comma, 1.88 meters per second. Okay? Then you were supposed to use the app and write the equation. Now, remember, the app does y equals mx plus b, but the app is dumb because it thinks we're graphing y. We're not. We're graphing v, and then you're supposed to write down the slope. Now, the slope is going to be whatever the app tells you, okay? But it should be in the order of like I'm going to say that 1.8, okay? But it should be something in that order, okay? In the order of something right around 1.8, depending on, again, on your data here, okay? Hey, I should mention also your data. Remember, it's the time from when Wes releases it until it gets to A, when he releases it to when it gets to B. So that means you needed to hit reset when you're doing it. Okay, so again, think. What is the car's acceleration? So that, and this should have been time. So as far as the car's acceleration, well, this slope, remember, slope equals rise over run. Okay, so if you think about the units, meters per second, oh, that's going to be my slope. So whatever the app told you for the slope. Now, I'm going to tell you again, if I get a whole bunch of people that say 1.8, that means you didn't actually freaking think. Okay, you didn't do anything. This is not about just copying me. It's about doing it and understanding. You know, so I'm going to say 1.8 meters per second squared, but you are not going to do that because you're going to actually do it and see what the app comes up with. Okay, number 4 says, what is the shape between this graph and the x-axis? Oh, well, look. That would be a triangle. Oh, well, to find the area of a triangle, you do 1/2 base times height. And if you take a look here, if I was to go 1/2 base times height, for me, now again, you are doing your own. Okay, so if I see these same numbers, I'm not going to give you credit. You're going to have to do your own and think. But my base is, the base of this triangle is 1.0875 seconds. The height of that triangle is 1.882, or just, I guess, 1.88 meters per second. All right, you ready to do some algebra, people? All right, watch. Seconds goes away. My goodness, I know. So that means I'm going to end up with meters. So if I take 1.88 times 1.05 times 0.5, I get this number. Now, this isn't perfect, but that's okay. Okay, I get 1.022 meters. Well, what is the 1.022 meters? It should have been this displacement, because if you look, that's my displacement, which is right here. Now you're going to do it by yourself, and you're going to see how close you get. Okay? Again, you're not memorizing. You're going to see how close you get. Okay? All right. We're done with the first page. Now we're going to go on to the second page. All right. So we have our displacement versus time graph. So on our displacement versus time graph, it should have looked something like this. Again, we're going to pretend I got that same D point, which I got 1.2 meters and 1.0875 seconds. Okay, so this point would be 1.0875, comma, 1.2. Okay. Then you were supposed to find the slope. So if I draw a tangent line, does everybody see how that tangent line only hits at that one point? Everybody see that? Then the slope of this graph, well, I don't want to memorize. I'm going to think. So the slope is rise over run. So if the slope is rise over run, that's meters per second. Oh, what is that? That's velocity. Oh, wait, this was point D. What was my velocity at point D? Oh, yeah. That was my velocity at point D. Okay, so again, I'm thinking, I'm understanding. Okay? All right. So that should tell you this. But again, you are doing your point. If you pick point D, I'm not going to count it. Okay, you have to do it yourself. You have to think about it. Okay, then you are supposed to linearize the graph. So do you see over here where it says linearize? You are supposed to tell me what you actually did in this one, and then show me the data here. Okay, so you'll have to do that too. And then if you're linearizing it, this should have come out. This should be x, and this should be t squared. And yes, it should come out to be a line. And then you should have solved for the equation. Now, again, this is y equals mx plus b. But then you have to be smart. Did I graph y? No, I graphed x. And then your slope should have been some number. And I'm going to say, now, again, you're going to do it yourself. Okay? I'm going to say that this number came out to be 0.8. Okay? Now, did it actually come out to be 0.8? No, but you are going to actually graph it and see what the app says. And then my x is actually t squared. So there's that. Now the slope has units. Okay? If you look at the units of this slope, okay, hopefully that didn't freeze up on you. If it did, sorry. But the slope has units. If you look at the units of this slope, it's rise, which is meters over run over meters squared. So my slope here is meters per second squared. Okay, rise over run. You might think that that's acceleration, but it is actually telling you that it's 1/2 the acceleration. So if I got a slope of this, then that's 1/2 the acceleration, which means my acceleration, according to this graph, is 1.6 meters per second squared. Well, if I look back to what I got over here, I got 1.8 meters per second squared. So then for me, I would go, oh, change, the difference would be 0.2 divided by the actual, which I'm going to use, I think it says, the actual would be what you think it is. I would go with probably the other one, which is 1.8. So I would say the difference, which is 0.2 over 1.8, because I'm going to say the other one is more accurate. And then I had multiplied by 100, and I could find my percent here. Okay? All right. The rest of this is on the other. It's all explained in the other video, so make sure you watch the other video. All right. Moving forward, people, you are going to take the time right now, and you are going to say to yourself, I am going to understand. I am going to work hard to make sure that this makes sense to me. Okay, you can do it. I believe in you. All right. Bye, kids.